This is Josh White with JW Math Tutoring. In today's video, I'm going to highlight 16 repeat problems that appeared on the March 2026 Digital SAT Math exam that I've covered before in one or more videos. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
This is Josh White with JW Math Tutoring, and this is the third video in my March 2026 SAT Math official test problem set series. This is going to have all of the repeat questions highlighted in it. So I'm going to go through, basically mention the questions that have been self-reported that I came across, which were covered in a previous video, and a lot of them have been covered multiple times. So these are not going to be worked out in detail, unlike the first two videos with the new problems. Instead, I'm just going to briefly mention the question, and you can see, the months and years and, worksheet number and problem number where they were featured previously. And based on the suggestion of a subscriber to the channel, the worksheet's now set up where I have the original Reddit comments, that were mentioning these problems listed here. And then above that, I have a copy of one of the example problems from one of the worksheets. Okay, so you can download this worksheet. There'll be a link in the description, link in the pinned comment, and you can go ahead and basically do the problems out if you want. Of course, that are already listed on here. Of course, if you do want to check your answers, you would have to go to the video and just confirm your answers in that. All right, so as I said, if you haven't done so already, check out videos March 2026, basically video worksheet number 1, and also worksheet video number 2. Those have all new problems in them. Otherwise, let's just go ahead and run through these. So first one is the predator and prey one, where they both start off the same, and then one increases by some percent, another increases by a different percentage, and at the end they want to find, one of them is whatever percent less than the other, or sometimes it's whatever is, one of them is 1%, whatever percent greater than the other. Anyways, very common question. We've seen it for over 2 years now. First seen it way back in June 2024. All right, the next one, second question overall. Basically, there's two cylinders. You're told that they are similar. You're given most likely the volume of each of them, and then you're also given some other piece of information about one of them, either the radius or the height. And essentially, you use all that information to find the surface area of both the cylinders, and then it could ask for the difference between them. It could ask, there have been questions where it asks for the sum of the two surface areas. But either way, you can see the months on the screen there that this was previously reported. Go back, watch the solutions to, in at least one of those problems. All right, next up, this should be question number 3. Basically, standard quadratic where you have a ball or something. Starts at a certain height at time t equals 0. Usually it's a 0, 0, but it doesn't have to be. And then they give you the vertex for it. And ultimately they want to know what the height is at some specific time. So what's the height at 10 seconds, or what's the height at 8 seconds, or whatever. And you go through and you can basically construct the quadratic, quadratic regression. And then once you do that, either plug in the number or you can get it, from the graph. In any case, you can see this one in the months, that worksheets and so on that are listed on the screen. And also keep in mind, this is identical to one of the Blue Book practice test questions as well. That should also say, I got to correct that. In the worksheet, it should say module 2B there. It's the harder of the 2-second modules. All right, next up. Here you have the problem where basically you have a right triangle. You're given generally 2 of the sides, and you're also told that the area of it is equal to like in this, like k cosine times a, which is basically one of the angles, and they want you to find the value of k, basically the value of the constant. So this one was covered twice, last year, 2025. So go check out either of those, solutions or problems. Of course, one of them's listed here, already on the screen, the one from June. All right, let's move on to the top of the second page now. There was a report of a question asking about what is a factor of this given thing, of this given expression here. So there's one that's very similar to this. Back August 2025, you can see the specific problem on the screen here. I mean, basically you pull out a common factor and then you factor it as a difference of squares after that. So this one is going to be kind of the same basic idea. I don't think this one is set up quite correctly because you can see 16 is a square and 121 is a square, but q to the 13th is not a square. So the power on that q is probably incorrect, or there's possibly something missing with it. But this is the general idea of the problem. All right, next there was another kind of triangle trig question. So this is basically the one where you have an isosceles triangle and you're given the length of basically the base, like the two non-congruent sides, the other third side. You're given that length, and you're also given the measure of the angle, or the tangent of one of the angles in the triangle. All right, and then basically you're told to find the area of the triangle. So this, again, one that was featured August of last year. So go ahead, make sure you familiarize yourself with this problem. Next up, there was a report, you can see here, about being given some information and about what's sufficient to prove that, this triangle is similar to that triangle in terms of angle measures or side lengths, or, so on and so forth. Now, this is one where there could be multiple variations. I don't know exactly how the problem was set up and everything, so there could be minor differences between, say, the problem you see on the screen here and maybe the problem you had on the March 2026 test. But, it's the general idea of, here's some information about two triangles. Which of these answer choices, is sufficient to prove that they are similar, by the various methods that you can use. All right, moving to the top of the third page, there was a report about formula question. Okay, this one, again, it's identical to a problem that's now on one of the Blue Book practice tests. Again, that should be Module 2B listed there. That'll be corrected in the PDF file. But this formula can just very easily be solved in Desmos using regression. Go look up the videos. I would suggest looking up the newer one, October 2024, or even just going straight to Blue Book Practice Test 10. Although if you haven't done that yet, probably would not do. I would probably wait until you've completed that practice test if you want to look up the solution there. Next up, we have a common product of roots problem where there are three different parentheses all being multiplied by each other. You're told that the product of roots is equal to some number. Notice that two of them, basically, the roots are conjugates, and they are going to have square roots, basically in them. So this problem has been seen multiple times before. I mean, you can obviously see the months and the years and everything that are on the screen there. It can be solved in Desmos, can also be solved by hand as well in terms of how you set it up. But make sure, again, you familiarize yourself with this problem. All right, the next one, there's a report about a problem basically where you have two groups and you're trying to find the combined mean of, every value from those two groups. Essentially, it's the concept of like a weighted average, but you can do it in Desmos as essentially set it up as a frequency table and just like calculate it that way. So the previous example that we saw back in May of last year was with penguins, like two groups of penguins and everything. Not sure exactly what the specific item referenced in this one was. You can see the text, on the screen there. But in any case, definitely a good problem to be familiar with and be aware of. All right, next up, this was a question I saw mentioned a lot. You'll see variations of this. Basically, what happens is it's an equation. It's set up as a proportion, and you have the same exact expression on the top on both sides. So in this case, it's x plus 3, but it could just as easily be x plus 6, or it could be x minus 2, or whatever. The point is, it's the same exact expression over itself on the top, but the numbers on the bottom are different. Okay, and then the question will always ask in which interval is, and then it'll put the expression on the top located in. All right. Now, for every example that we've seen of this, basically the value of that expression on the top has to equal 0. That's the only way that like something over 5 can equal something over 7 is if it's 0 over 5 and 0 over 7. Any other number over 5 would not equal that same number over 7. So the answer is always going to be 0. So then you have to just pick which interval 0 is technically located in. All right, next up, there was a report about basically a square being inscribed in a circle, and you're given usually either the radius or the diameter or something, and then they told to find the, the side length of the square. So if you're interested in this problem, go check it out. Featured in May of 2025 last year. Next up, a common problem that's been featured many times. Basically, it's an exponential function. You're given 2 points. They both have a constant in it. Usually it's c. And then they ask, what could be the value of b in this exponential function? All right, so this is one that can very easily be done in Desmos very quickly as well. Again, it's been featured multiple times. You can see the months and years on the screen there, but definitely good to make sure that you know how to do this one. Now, after that, we had a report of basically what I call an advanced percentage problem. This is a problem where you have like, you basically have 3 different equations. A is some percent of B, and A is some percent of C, and B is what percent of C, or, things like that. This one was a little bit different in that the initial equation, is like A is whatever percent of the sum of B and C, but you still set it up and solve it the exact same way. Basically it can be done in Desmos using regression with lists, and you can get the answer very quickly and very easily. Now, if you notice on the screen here, there's a ton of times where these specific problems have been featured, right? So, if you're going to pick one of these, I would ideally look for the older one, or sorry, excuse me, the newer ones. You want like October 2025, August 2025. Basically, anything from 2025 would most likely be better than 2024, just because to make sure it has the the newest Desmos techniques in it. All right, top of the next page. So this is one that came up multiple times last year. Essentially, it's an equation. You've got something to the 2n root power, or however you want to say that. The index is, the radical is 2n. This can very easily be solved in Desmos, because basically you just raise both sides to the 2n power, and then it turns into a quadratic, essentially. So go ahead, check this one out. This one, the direct question image was posted on the comment for it, or the post for it. So you could here practice solving either of these and see if you can get the correct answers. All right, let's continue. There's another question about you're given some angle in radians, and then it says another angle is so many times that, 3 times that, 18 times that, whatever it is. But it wants to know what is the measure of this other angle in degrees, not in radians. So you're taking the original angle, you are multiplying it by whatever number, because this new angle is bigger than it, and then you are multiplying by the appropriate value in order to convert from radians to degrees. Okay? And then you're basically asked which expression, is the angle in degrees there. So this I think it was first reported in September of 2025. All right, so that's it for these basically what I call repeat problems. I think there were 16 problems in total that I found. Now, one thing I do want to mention is that there were a couple problems that came up on this March 2026 exam, which had been featured previously, but I am going to include in the new problems videos just because, first of all, they had not been featured since basically 2024, and also they were very common and discussed questions, meaning basically questions that it seemed a lot of people had on their exams. So even though they were featured previously, I am going to include them in the new questions videos just to go over them in detail, for basically for a second time. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. As I mentioned earlier, check out the videos, worksheets for part 1 from March 2026, and also part 2 from March 2026 as well. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are two versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.